This section is the last section of Chapter 3, and this is dealing with unions and intersections of sets. So we're going to first look at something called a union. What I would do is I would suggest that you write down this section of it and pay special attention or make special note that this is the union symbol. Okay, so the union of two or more sets is the set that contains all elements of the sets. The symbol is kind of like a horseshoe or just a U without the little tail on it. What it means is that anytime you take two sets, we want you to think of it, we're going to use, this is called the Venn diagram. You've seen them in class already. But it's essentially just a visual representation of what we're talking about. So we're going to say that this is U for the universal set. So this is everything that we're talking about. A is one set of things, B is another set of things. The union is anybody that falls in or anything that falls in these circles. So for instance, if this was the universal set was all students that go to BHS, and set A was all the freshmen, and set B were boys. Okay, set A is freshmen, set B is boys. The union of this would be all freshmen and anybody who is a freshman or a boy. Okay, so A is all the freshmen, B is all the boys. You notice right here that this little area right here is in both circles, and that would be freshmen who are male, who are boys. Okay, which we'll talk about that a little bit later, but that's our union. Okay, so here's how this works. In your left pocket, you have a quarter, a paper clip, and a key. In your right pocket, you have a penny, a quarter, a pencil, and a marble. So left pocket, quarter, paper clip, key. Right pocket, penny, quarter, pencil, marble. We want you to write the union of the set. So we write it as set L union set R. So we have to write anything that is in either pocket. So we start by writing quarter, paper clip, key, penny. We already have quarter, so we don't put it twice. Okay? We don't put this one twice because it's already down. Pencil, marble, and that's the union. So that's how we write that. The intersection now is the upside down horseshoe or the upside down U. I always think of it as it almost looks like an A. We're just missing that right there. And the reason I think of it as an A, it's because anything that lands inside A and B. So it's this right here. So again, if this is all the students at BHS, and set A are freshman students, and set B are students who are male, this would be freshman male students that land right in here. These would be the freshman females. These would be boys who are not freshmen. Okay. A disjoint set. So again, I would definitely write down actually this entire slide. A disjoint set are sets that have nothing in common. So for instance, set A, if we change this up, set A could be all the juniors and set B could be all the seniors, or set A be all the females and set B be all the males. So the intersection, right? The intersection of these two sets. So we're looking for things that are in both. So we're looking at the intersection of x and z. So x is a natural number less than 19. So you remember natural numbers start at 1, so we're basically talking about any number between 1 and 18. Set z is a multiple of 6, so things where 6 goes into. So that would be 6, let's go over here, 6, 12, 18, and so on. And so which numbers do they have in common? They would have the numbers 6. 6 is in there. 12 is in there, and so is 18. So x intersection z is equal to 6, 12, 18. The intersection of y and z, so again, z we already know, z is 6, 12, and 8. And y is an odd integer, so we're talking 1, 3, 5, 7, 9, and so on. Which one of these do they both have in common, 6, 12, 18? And the answer is none of them. And so therefore, y intersection z equals the empty set. And let's do this a little bit different. Set A is 2, 4, 6, 8. Set B is 0, 2, 5, 7, 8. And set C is any odd whole number. What is A intersection B? A intersection B is equal to any numbers that A and B have in common. So we got the 2, no 4, no 6 over here, and 8. So we've got the 2 and the 8. The intersection of A and C are what numbers does A and C have in common? What odd whole numbers are in A? The answer is none of them. So that's an empty set. And then the intersection of C and B is what odd whole numbers are in set B. No, no. 5, yes. 7, yes. 8, no. So we're looking at just 5 and 7. Okay. We can create Venn diagrams to help us out with this. So if we were looking at 3 different friends who are going camping, and we're kind of looking at, all right, are there things that maybe we're missing or things that maybe we all are taking that we don't need to each take? We look at it like this. In the yellow bag has a flashlight, glasses, a pan, water, hat, and a map. The red bag has rope, first aid kit, pan, water, hat, and map. You notice the pan. The pan is in which bag or bags? The pan is in both the red bag and the yellow bag. So each bag has a pan. Notice it's not part of the blue bag, but water, hat, and the map are part of them. The only person who has a rope is the red bag. In the blue bag, you have a camera, first aid kit, water, hat, and map. The blue bag is the only one that has a camera, but it does have a first aid kit, which the red bag also has. So that's kind of how you read this Venn diagram. It's a really good visual representation. All right. And then lastly, so let's just try a little bit more of this. Number 1, X union Y. So these are any things that are in either X or Y. So that would be, I'm going to write down basically anything that's in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are 1 through 10. The numbers in here that match up are 2, 4, 6, 8. So it's essentially everything that's in X. 2, 4, 6, 8, 10. Those are the numbers that, sorry, got myself. I was doing the intersection. The union is anything that's in either X or Y. So everything in Y is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Is there anything that we missed that's in X? And the answer is no. So that is our union. This is the one that I was doing. The intersection is anything that they have in common. And that is 2, 4, 6, 8, and 10. 3 was X intersection Z. So these again are what things do X and Z have in common. X's are all the evens, Z is all the odds. So what do they have in common? Absolutely nothing. And then finally, the union of Y and Z. So these are all the things that are in a Y or Z. And again, since Y is 1 through 10, and Z doesn't have anything that's not 1 through 10, it's just going to end up being these numbers. That is it for this section. We will see you tomorrow.